relational database methods. So we have new problems to solve and new methods. And examples of big data: Walmart handles more than 1 million customer transactions per hour. Facebook has 40 million photos from each of its users. And decoding the human genome originally took 10 years, but now we can do it in 1 week. So what is big data? Big data is a term for data sets that are so large and complex that traditional data processing applications are inadequate. So therefore, this presents a lot of new challenges for what the analyses are: the capture, the data curation, search sharing, storage, transfer, visualization, querying, updating, and information privacy. So we need to have an increase of storage capacities, processing power, the availability of data, and we have so much data that's generated bytes per day. So we have 294 billion emails are sent every minute, Facebook 2 million blogs posted or written, and so forth. And so in 60 seconds, here's our spectrum of things that happened in big data of what we have. We have 694,000 search queries, 168 million emails are sent. So this is just an example of what can happen in 60 seconds in big data. Okay, here's my video here. I need Andres. No, I need Andres.
You don't need Andres, you need self-confidence. Imagine.
No.
We need popcorn.
Yeah, he had it working. I need him. Where's Andres? Where's Andres? Can somebody get Andres?
Hi, I'm
okay, here.
And I'd like to welcome you to Techniques and Concepts of Big Data. Big data refers to data that, because of its size, speed, or form.
Big data too.
Yeah, I know. Well, yeah, he got it to work the right way, the right speed.
Are you using internet?
No. Andres had it to work the right speed when he came. Velocity and variety, data quantity, data speed, and data types. And these intersect in defining different structures: unstructured, semi-structured, or all of the above. Volume could be terabytes. Velocity, how fast is it going in velocity? So we can talk about volume, velocity, and variety of data, but we also can talk about the variability and the complexity of data also. And so big data, here we have other examples here of examples in retail, consulting, air transportation, construction, food products, steel, automotive, and so forth. In our immense amount of data that we're collecting, we have examples of volume, variety, and velocity. And so these all intersect with each other, in which the big data reduces cost, makes processes more efficient, detects risks and checks frauds, understand customers' needs better. And we have, here's an example of big data in the healthcare sector. We have, as one particular application, I have some other ones going on, but the dimensionality of data is important. Big data is the frontier of a firm's ability to store, process, and access all the data it needs to operate effectively, make decisions, reduce risks, and serve customers. And so here we have an example of an exabyte and a zettabyte. The big data from Facebook, Yahoo, Amazon.com, eBay, and Google. Exabyte blankets the West Coast states. A zettabyte fills the Pacific Ocean of amounts of data. And yottabyte is an Earth-sized rice ball. So big data is not about the size of the data, but also about the value within the data. And this is a video. Let's go back. I have a video clip here, but it's not visible. Okay, so we have applications in healthcare and customer service and insurance. Here's examples of where government and the private sector uses big data. The City of Dublin in congestion and traffic management, City of Stockholm, traffic patterns and congestion, Lufthansa, Air France, Swiss International, different airlines for revenue management, and Munich Airport, competitive advantage and technical enhancement. Okay, big data in banking. Banks are faced with finding new and innovative ways to manage data. Big data in education. Identify at-risk students, make sure students are more adequately have progress, can implement a better system for evaluation and support of teachers and principals. Big data in government, managing utilities, running agencies, dealing with traffic congestion, or preventing crime. Big data in healthcare, patient records, treatment plans, prescription information. Big data in manufacturing, we have more and more manufacturers are working in an analytics-based culture, which means they can solve problems faster and make more agile business decisions. So optimization, modeling, execution monitoring, business process management life cycle. Big data in retail. Here we just have a picture of different icons of different companies, corporations that use big data. And retailers really need to know the best way to market to customers, the most strategic way to bring back lapsed business. Big data remains at the heart of all these things. So here are some awesome ways big data is used to change our world: understanding and targeting customers, understanding and optimizing business processes, personal quantifications and performance and optimization, improving healthcare and public health, improving sports performance, improving science and research, optimizing machine and device performance, improving security and law enforcement, improving and optimizing cities and countries and financial trading. Understanding and targeting customers, we need to create predictive models, better predict customer churn. Walmart can predict what products will sell, and car insurance companies understand how well the customers actually drive. Even government election campaigns can be optimizing using big data analytics. Understanding and optimizing business processes. Big data is used for supply chain and delivery route optimization. Retailers are able to optimize their stock based on prediction generated from social media, web search trends, and weather forecasts. Personal quantification and performance optimization. We can now benefit from the data generated from wearable devices such as smartwatches or small bracelets. Certain companies can collect 60 years worth of sleep data every night, and analyzing volumes of data will bring entirely new insights it can feed back to individual users. Most online dating sites apply big data tools and algorithms to find more appropriate matches. So we can improve healthcare and public health, improving sports performance, using Spartan technology to track nutrition and sleep, improving science and research. CERN is a Swiss nuclear physics lab, which is large collider, the world's most powerful particle accelerator. Experiments to unlock the secrets of our universe, how it started and works, generates huge amounts of data. Optimizing machine and device performance. Big data tools are used to operate Google's self-driving car. Big data tools are also used to optimize energy grids. Improving security and law enforcement. The National Security Agency uses big data analytics to foil terrorist plots. Police forces use big data tools to crunch criminals and even predict criminal activity. And credit card companies use big data to detect fraudulent transactions. Improving and optimizing cities and countries. One of our keynote speakers talked about this afternoon. Big data is used to improve many aspects of our cities and countries. For example, it allows cities to optimize traffic flows based on real-time traffic information, as well as social media and weather data. Financial trading, we have big data algorithms used to make trading decisions. Here we have examples of using big data in medical records in the cloud. Performing platforms support MapReduce, and MapReduce is used as a monad. So here are factors driving interest in big data analytics: finding correlations among multiple disparate data sources, predicting customer behavior, predicting product or service sales, predicting fraud or fraudulent risk, analyzing social network comments for customer sentiment, identifying computer security risks, analyzing web click streams, etc. And so here we have sort of like a filter type thing. We can, in our sieve here, we can put all sorts of big data from SAP, Google, whatever. We can validate, blend, enrich, and sculpt, but we connect the data from, and then we view it, then we transform it, and then we can publish the data. So here we have a big data software platform which involves business predictive models, customer predictive models, real-time analytics, and so forth, that we use these all together to generate information about big data. And big data can be structured or unstructured in format. Okay. I have a video back here, which I couldn't see if we can get to show. Yeah, I know this one right here, explaining big data right here.
Click here first.
Click here first. Okay, good. Okay. Yeah,
Welcome to another video from explainingcomputers.com. This time I'm going to talk about big data. This is the next big thing in computing and generates value from very large data sets that cannot be analysed with traditional computing techniques. The quantity of computer data generated on planet Earth is growing exponentially for many reasons. For a start, retailers are building vast databases of recorded customer activity. Organisations working in logistics, financial services, healthcare and many other sectors are also capturing more data. And public social media is creating vast quantities of digital material. As vision recognition improves, it is additionally starting to become possible for computers to extract meaningful information from still images and video. As more smart objects go online, big data is also being generated by an expanding Internet of Things. And finally, several areas of scientific advancement are starting to generate and rely on vast quantities of data that were until recently almost unimaginable. Big data is often characterized using the 3 V's of volume, velocity, and variety. Here, volume poses both the greatest challenge and the greatest opportunity, as big data could help many organizations to understand people better and to allocate resources more effectively. However, traditional computing solutions like relational databases are not scalable to handle data of this magnitude. Big data velocity also raises a number of issues, with the rate at which data is flowing into many organizations now exceeding the capacity of their IT systems. In addition, users increasingly demand data that is streamed to them in real time, and delivering this can prove quite a challenge. Finally, the variety of data types to be processed is becoming increasingly diverse. Gone are the days when data centers only have to deal with documents, financial transactions, stock records, and personnel files. Today, photographs, audio, video, 3D models, complex simulations, and location data are being piled into many a corporate data silo. Many such big data sources are also unstructured and hence not easy to categorize, let alone process, with traditional computing techniques. Due to the challenges of volume, velocity and variety, many organizations at present have little choice but to ignore or rapidly excrete large quantities of potentially valuable information. Indeed, if we think of organizations as creatures that process data, then most are rather primitive forms of life. Their sensors and IT systems are simply not up to the job of scanning and interpreting the vast oceans of data in which they swim. As a consequence, most of the data that surrounds organizations today is ignored. A large proportion of the data that they gather is then not processed, with a significant quantity of useful information passing straight through them as data exhaust. For example, until recently, the majority of the data captured by retailer loyalty cards was not processed in any way. And almost all video data captured by hospitals during surgery is still deleted within weeks. Today, the leading big data technology is Hadoop. This is an open source software library for reliable, scalable, distributed computing and provides the first viable platform for big data analytics. Hadoop is already used by most big data pioneers. For example, LinkedIn currently uses it to generate over 100 billion personalized recommendations every week. Hadoop distributes the storage and processing of large data sets across groups or clusters of server computers. Whereas traditional large-scale computing solutions rely on expensive server hardware with a high fault tolerance, Hadoop detects and compensates for hardware failures or other system problems at the application level. This allows a high level of service continuity to be delivered by clusters of individual computers, each of which may be prone to failure. Technically, Hadoop consists of two key components. The first is the Hadoop distributed file system, which permits high bandwidth cluster-based storage. The second is a data processing framework called MapReduce. Based on Google search technology, MapReduce distributes or maps large datasets across multiple servers. Each server then creates a summary of the data that's been allocated. All of this summary information is then aggregated in the so-termed reduce stage. MapReduce subsequently allows extremely large raw datasets to be rapidly distilled before more traditional data analysis tools are applied. For organizations who cannot afford an internal big data infrastructure, cloud-based big data solutions are already available. Where public big data sets need to be utilized, running everything in the cloud also makes a lot of sense, as data does not have to be downloaded. For example, Amazon Web Services already hosts many public data sets containing government and medical information. Looking further ahead, quantum computing may greatly improve big data processing. Quantum computers store and process data using quantum mechanical states and will in theory excel at the massively parallel processing of unstructured data. As IBM explained, big data provides an opportunity to find insight in new and emerging types of data. Or as Oracle put it, big data holds the promise of giving enterprises deeper insight into their customers, partners, and business. In time, big data may also help farmers to accurately forecast bad weather and crop failures. Meanwhile, governments may use big data to predict and plan for civil unrest or pandemics. In a recent report, the McKinsey Global Institute estimated that the US healthcare sector alone could achieve $300 billion in efficiency and quality savings every year by leveraging big data. Across Europe, they also estimate that using big data could save at least $149 billion in government administration costs. In March 2012, the US government announced a $200 million investment in big data projects. By the end of 2015, Cisco estimates that global internet traffic will reach 4.8 zettabytes a year. That's 4.8 billion terabytes and indicates both the big data challenge and the big data opportunity ahead. More information on big data can be found on explainingcomputers.com. But now that's it for another video, and I hope to talk to you again very soon.
Okay, let me just pick up where I left off. I don't have much time. I'm just saying, here's the big data landscape, which I talked about. There are characteristics of big data, characteristics by industry here that I could talk about, big data opportunities, and so forth. There's visual toolboxes and so forth. Hadoop architecture was talked about in the video as well as MapReduce. And this compares traditional relational database management systems in MapReduce, what they can do, the structure of big data, MapReduce, and so forth. Big data analytics, big data plus content yields a big value. Real-time big data processing is a whole big important area. It also involves cloud computing and so forth. Here we have the top 10 in the world cloud structures for intensive computing using big data, storage systems from Microsoft and so forth. Amazon.com is number 1, and SoftLayer, Cloud Layers in Dallas is number 10. So the dramatic growth of mobile data, traffic data. So the question is, big data plus cloud computing equals question mark. That's what we go into the future. And the Internet of Things is also related to that. But big data is related to security in the cloud. And so we have, obviously benefits of big data, potential value of big data, the future of big data, $15 billion on software firms only specializing in data management analytics. The McKinsey Global Initiative estimates the data volume is growing 40% a year and grow by 44 between 2009 and 2020. So big data isn't big if you know how to use it. I have on my final video. This is.
Click the browser here.
Click here.
Here, the browser. You click the browser.
Shit.
Well, for the last 2 years, I've been editing and authoring a book called Research and Applications in Global Supercomputing. Supercomputing applications, which range from applications to bioinformatics, to nuclear energy, to philosophical logic of supercomputing, and applications in neurosciences and social applications and so forth. Basically, this has to deal with the field of big data. Supercomputers are essential for analyzing big data, intense amount of data.
Richard is doing truly cutting-edge research. When I talk to Richard and I hear about the projects that he's doing in his research with his books, it's an amazing testament to the things that we can do right here at the Arkansas State University College of Business. I am so proud of Richard and so amazed at the things that he's working on and developing, and it will be things that will benefit us not just as a college, but as a society for years to come.
That's my dean. So in any event, that's my talk. I'm sorry for the technical problems, but thank you for your attention, and I hope I'll be able to introduce you to the area of big data and the importance of it. I'm co-editing a book right now, Big Data Storage and Visualization Techniques, my third book, and I'm asking for contributing chapters for that too, and it's posted on the World Wide Web. So without further ado, thank you for your attention and being here.